So today we're going to be talking about mixture problems. Mixture problems are where you mix two either solutions together. It could be two different quantities of nuts, two different candies, three different things together to make a mixture. And so when you create a mixture, the properties of the two original things that you mix will change. So for example, if we have a quantity of acid, and this has 40% acid in it. And this has 70% acid, which I know seems weird because there's less. So you think, oh, why is 70 less? But it's less because you're putting less grams of that solution in it. So this is a 40% acid solution and a 70% acid solution. What percentage will the final solution have of acid in it?
110.
Okay, let's think about that. Can you have 110% acid?
No.
No. So this has 40% acid and 60% water. This has 70% acid and 30% water. That means if you mix them together, this one is going to have between 40% and 70% because it's a mix.
But you don't even know exactly how much.
We can find exactly how much, and that's what these problems are. Well, this has double the amount of that, right? So there's two 40s, right? Two 40s and one 70, because there's double this than there is of that. So that if we have 3 parts total, because we have 2 of this and 1 of that, what's going to be the total acidic amount?
50.
Yeah, it's going to be 50% acid.
Wait, so how do you know? Wait, why would you have 240s?
Because there's double the amount of the 40% acid than there is the 70% acid. Did you guys see?
I don't get it.
The 40% has 400 grams. The 70% has 200 grams.
Yeah.
So there's double the 40% than there is the 70%. So when you mix things together, you can't add the percents up, because as you guys recognize right away, that doesn't make sense.
Yeah.
You can't have 110% acid. So the mixture is going to have somewhere in between. But since we have more 40% than we have 70%, the amount of acid is closer to the 40% mark. Yes. Because we counted up 3 different parts. 1, 2, 3. Now this is not how we're going to do the problems. So I'm going to show you how we're going to do the problems, but I just wanted to demonstrate to you how you get from a 40% solution, a 70% solution, to a solution that's 50%. Because you're essentially mixing them together. It's like if you have a class that's half freshmen plus a class that's 1/4 freshmen, you don't mix them together and get a class that's 75% freshmen. You're going to have less than 50%.
So it's like making a new percentage.
A new percentage. And that new percentage is going to be in between these 2%. Okay? So, let's do a few problems. A mechanic has found that a car with a 14-quart radiator has 40% antifreeze mixture in the radiator, and she has had 80% antifreeze. How much of the 40% solution would she have to replace with the 80% solution to get the solution in the radiator up to 50%? A lot of percentages there. So let's write a table. Tables are going to be absolutely necessary in this. So I'm going to write amount times percent, and we're gonna write the percent as a decimal. And in this case, it's gonna equal the amount of antifreeze.
Is there minus here? With it's amount times percent equal amount of antifreeze?
Yep.
Okay.
Okay. So the reason why I have two lines at the bottom is because this is my mixture. Because I'm going to be mixing two percentages together. And it says she has on hand a 80% solution, and she has a 40% solution. So that means one solution is 40%, and one solution is 80%. And what she wants is a 50%. Wow. What she wants is a 50%. You guys see that? She wants to get 50%. So her desired percentage, her desired mixture is 50%. So 3 cups, yep. Now, in terms of the amount, it says the car has a 14-quart radiator. That's how much the radiator can hold. And so, in looking at the question, it says how much of the 40% solution, do you guys see that in the middle? How much of the 40% solution? So because I want to know how much of the 40% solution, I'm going to write the 40% solution as X. Because, yeah, exactly, because that's what I want to find. How much radiator solution am I going to have in total?
4.
Not percent, but how much? What amount? 14. So if I put in X, what more? How much more do I have to put in to get 14 total? 14?
Yeah. Well,
But if I have X quarts in there, 14 times X? Okay, let's think about this.
wait, I don't know what you're asking.
I'm asking what to write right there near that big cross-out thing that I'm doing.
Yeah, but you need 14 and you have X.
Okay, I need 14 total. So I need my mixture to be 14.
Yeah.
Okay? So I need my mixture to be 14. Let's say, ladies and gentlemen, looking forward here, this was 5.
Okay.
If this was 5, how much would this have to be? 9. Because they have to add up to 14. You're trying to fill up a 14-quart container. So if this one is X, what would this one have to be? Not me?
I have a question. How do you know it's 9?
No, I'm just saying a for example,
Oh.
to get people to think about what it would be. Okay, Brandon, you seem pretty excited.
Would it be 14 minus X?
It would be.
Oh, okay.
So the way you calculate the remainder is you take 14 minus X, because you used up X quarts of space. You have 14 minus X quarts remaining. Now to get the amount of antifreeze, the equation is at the top. Amount times percent equals amount of antifreeze. Please remember to deal with the percent as a decimal. So this is going to be 0.4x, 0.4x, and this is going to be 0.8. What's 0.8 times 14? 11.2 minus 0.8x. Okay, I'm just going to make my dots a little darker. Okay, questions so far? Now, your equation is going to come from this box right here. Because this box you can get 2 different ways. You can get it from adding down, or you can get it from multiplying across. So multiplying across, 14 times 0.5 is 7. So I can get this box two ways. From multiplying across, 14 times 0.5 is 7, or from adding down. If I add down, I get 0.4x plus 11.2 minus 0.8x. So 7 quarts equals the amount of quarts of antifreeze in the 40% solution plus the 80% solution. Okay, so you can calculate this by multiplying across or by adding down. Now, Pete, do you have a question? Any questions on how I got the 7? Any questions on how I got 0.4x plus 11.2 minus 28x? Okay, let's solve it. Gonna combine like terms. Then I'm going to subtract 11.6 on both sides. Oh, darn it. Okay. Okay, so I combined things I shouldn't have combined because I forgot the x by the 0.4. So be careful. And I'll divide both sides by negative 0.4.
Isn't it negative 4.2? Yeah. Wait.
So we're getting X by some.
Oh, I see. Wait. No, I'm wrong. Go ahead. Yeah, that's right. If you move, well, it's 1.05, but then if you move the decimal once, then it's 10.
Okay. Questions on that? So X is the amount of 40% solution, and it says how much of the 40% solution. How much? Well, it's 10.5 quarts, because I got X is 10.5. Questions about that one?
So, when you say it has to be reduced fraction from the whole number, you mean like
Oh. Oh, gosh. Okay, I'm sorry. Forget that happened.
What happened?
I think just 10.5 was what I was indicating, but who really cares? 10.5, 10.5. So let's not overcomplicate things. But thank you for reading, because I really didn't read my own problem. All right, let's do another one. Okay, so we have a 20-pound bag of Economy brand cement, contains 25% cement and 75% sand. How much pure cement must be added to produce a cement mix that is 40% cement? All right, so it's a mixture problem, you're mixing. So we're gonna do, and my last row is a double line, and it's amount times percent equals, and this is gonna be, we're talking about percents of cement, so now it's not amount of antifreeze, it's amount of cement. Okay. 20-pound bag contains 25% cement. So for that one, we know the amount is 20 pounds, and we know it contains 25% cement. The 75% sand is just extra information. They're just telling you what else is in the bag. But since we're all talking about cement, notice it's pure cement, 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 cement. The sand part is extra information. Okay, so this is the economy. How much pure cement, so this is pure cement, and it says how much. So since I'm asking how much, my amount is unknown. So I'm going to call that X. If it's pure cement, what's my percent? 100 is all cement. How much pure cement must be added in order to produce a cement mixture that's 40% cement? Yep, we want the mixture to be 40%. So this is our mix. Now, when we look, what is my amount of my mixture, my economy plus my pure? What goes in here for my amount? Yep. Is it minus? What? 20 plus X. Because you pour them together. Like you pour in the economy, you pour in the economy and then you pour in the pure stuff. So it's just all being added together. So the mixture, this gets added. And then the amount of cement, this is 20 times 0.25. This is 5 pounds of cement. What goes right here? X, good. Because remember, we write that as a decimal. That's X times 1. 1X. And remember how we generate this cell. We generate it 2 different ways. We generate it by multiplying across, and we generate it by adding down. So 20 plus X times 0.4, that's multiplying across, equals, and what do I get when I'm sorry, yeah?
Can you just put down the
Sure, if you want to multiply it out, if you don't want to do that,
yeah.
it would be 8
It would be 8
plus
plus
0.4x multiplying across equals, and what do I get from adding down?
Wait, how does it follow through with the other one?
So 0.4 times 20 is 8.
Yeah.
0.4 times x is 0.4x.
But like, what would you put on the other side? On the equal sign, and the other.
Same thing that I'm going to put right now.
It would be 5 plus X.
5 plus x. Good. So in all of these tables, you add down because we're adding cement, and then we add more cement. So it's just like a scale. Like you step on the scale, someone else steps on the scale. Those just get added together. Here, you put economy cement in the bucket, and then you add on pure cement in the bucket. It's just as additive, it adds up. So then your equation is 8 plus 0.4x equals 5 plus x. I'm going to get the x's on the right because then they'll be positive. So this is 1x minus 0.4x, 0.6x.
Max Stowell, Aaron Dobbs, and Stephen Clinter. Please report to Ms. Runker's office.
Yes.
So why would it be 5 plus x and not 5x?
Okay, because when you think of amounts being combined, you have this much on a scale, and then you're putting more on the scale. Those just get added together.
Okay.
So going across the table, left to right, multiplying, because you're,
Seniors, remember to bring a lunch tomorrow when you come for your graduation order turn-in day.
because you're using this formula, amount times percent, but going down the table, you add. And it looks like it's going to be 5 pounds. There you go.